Welcome to the notes on relations, domain, and range. This right here is page 4 of the notes. You will have access to this. We'll scroll through this slowly for right now. If you need to refer back to it, you can always back up the video. Here's some terminology that I'm going to be referring to. You can pause the video and write down terminology, the definitions at any point. Y coordinate. One that I want to point out is this discrete graph. It's just a bunch of unconnected points, where a continuous graph is all the points are connected, so it looks like one smooth curve. Right, so we are going to start here with parts of the plane. And if you guys will pause the video and think about what the origin, quadrants, x and y axis, if we're going to label those. Right. Most students are fine with where the origin is. It's right here in the center where the x and y axis meet. The x and y axis, the only difficulty I generally find is with quadrants, naming them. It does go counterclockwise, starting here, 1, 2, 3, 4. Okay, so we have our definition of an ordered pair. Okay, an x, y, just coordinates of a point. And we're going to look at a few examples here. So point A, we want to write that as an ordered pair. So remember, it's always x then y. This is the x-axis. We'll label it here, x, y. And when you name your ordered pair, you always move the x-axis first. So 1, 2, 3. So my x-coordinate is -3 because I went 3 to the left. 1, 2, 3, 4. I went up 4, so my y-coordinate is 4. Quadrant, remember how we named it? We went 1, 2, 3, 4. So this is quadrant 2. Now would be a good time for you guys to pause the video and try the remainder of these on your own. Okay, most of these are now filled in. See how you did. The one that students struggle with are C and F. So C, to get from the origin to C, I have to move 0 units left or right. So my x-coordinate is 0, and I have to move up 2, so it's 0, 2. Now that is not in a single quadrant. It's not in quadrant 1, it's not in quadrant 2, it's on the y-axis. So for quadrant here, this should say quadrant or axis. We're actually going to put here y-axis. Okay. Same thing with 5, 0, F. F, we have to move 1, 2, 3, 4, 5 to the right, but we move 0 units up or down to get to point F. So 5, 0. And again, it's not in quadrant 1, it's not in quadrant 4, it's on the x-axis. So we just write in here, x-axis. Okay. Again, you've got your definition here of discrete graph, continuous graph. All right, so what is a relation? It is just a set of ordered pairs. Okay, so you've got a set of ordered pairs right here, right? -3, 1, -2, 0, 1, 2, and these little squiggly marks on the end. That's how you show, that's how you name that you have a set. That is what's called set notation. Right? The set of all x values is called the domain. The set of all the y values is the range. Right? So you can see here, we've got it written as an ordered pair. We've got this relation written as an ordered pair. And then I've got it transferred to a table, and I've got mapping and graph. So you see -3, 1 here is an ordered pair. In the table, I have -3, 1. In mapping, I have -3 in the x bubble and 1 in the y bubble. There's nothing wrong if you label this as your x bubble and your y bubble. It's just a table written slightly different. Now, what you will find mapping sometimes is they won't necessarily be across from each other. So like 3, -4, I've drawn a line connecting 3 to -4, which tells me 3 and -4 are an ordered pair. -3, 5, that's an ordered pair. Right? And of course, over here, I have the points graphed. Here, I named them by letter, and you can see I've got them labeled by letter. Now, the only thing we still need to do is work on domain and range. So my domain, remember we want to use the set of all x values. So I'm going to use my set notation. And all I have to do is pull out or call out the x's. It's probably easier to use the table. One thing I want to note is if you have the same number twice, -3 and -3, you don't have to say it's in the domain twice. You usually put the domain and range in increasing order. So my first x is -3, got -2, 1, 3. And again, notice I don't write -3 a second time. I've already said that -3 is in the domain. Range, it's all my y's. Normally written in lowest to highest order. So I'm going to start actually with -4. My next highest value is going to be 0, then 1, 2. And my largest y value is 5. Okay, so again, notice that I'm using the set notation to describe domain and range, or to name domain and range. Okay, so now would be a good time for you guys to pause the video and write this relation in table format, in mapping format, graph it, and name your domain and range. All right, you guys can see how you did here. Here's the table. Notice that in my mapping, you're only going to find the 4 one time. You only have to put it once. Since the -1 goes with 4, I draw a line to connect -1 with 4. Since the 2 goes with 4, I connect the 2 with the 4. But I don't have to write it twice. Just like when I write my domain and range, I don't have to write the 4 twice. I've already said 4 is in my range. I don't have to list it twice. And here's the graphing of it, the graph of it. All right, so let's talk about domain and range of continuous graphs, graphs which you can draw without lifting your pencil, basically. All right, so we are interested in domain and range of continuous graphs. So it says for domain, scan your pencil. I like to think of it also as your eyes. Not everyone has to put their pencil down, but you can put your pencils down. From, and then domain, remember, is your x's. We're going to scan along the x-axis. And what direction does the x-axis move? Left to right. Does not move up and down. Right? So I'm focused on how far left my graph goes and how far to the right my graph goes. For the range, scan your pencil / eyes from bottom to top. We're going to go up, down. So we're going to go bottom to top. And again, if I'm going up and down, that is the y-axis. Okay, so I'm going to do this one first. So you can see the only thing that's graphed here is this circle. And the way that I do this is I make a marking for, if I move my pencil along my curve, what's the leftmost point that I ever hit? Well, it's this right here. So the furthest left it goes is right here, this point. So I'm going to draw a line through that. And then as I trace my pencil along my graph, my rightmost point is right here. Draw a line through my x-axis. Now, the furthest left, this line And for domain, that's the x's. So I'm going to focus on the x-axis. So 1, 2, 3. So I can see my domain, the furthest left it goes is -3. And this is the furthest to the right, that's 1, 2, 3, +3. Now, you've got to be real careful of just thinking of whole numbers in here, because there's a lot of numbers, because some people want to go -3, -2, -1, 0, 1, 2, 3. But what about 0.2? What about -1.5? What about 2.9? What about 1.7893? What about -0.5219? There's all kinds of numbers between -2 and 3. We don't want to just pretend we're living in a world where there's just whole numbers. So it's everything that's between -3 and 3. So we want to say x, which is the domain. Of course, all these numbers in here being between -3 and 3 means that they're smaller than 3 because they're to the left of 3. They're bigger than -3 because they're to the right. So we want to say x has to be less than or equal to 3, but at the same time, x has to be greater than or equal to -3. And then for the range, I'm going to do the same thing. I'm just going to change the color here. Okay. Now the range is the y. So now I want to go along the y-axis. So as I trace my graph, which is a circle in this case, the highest point is right here. Draw a line through the y-axis. Again, as I follow my curve, my lowest point is right here. Draw a line through it. Now this hits the y-axis at 1, 2, 3. This hits the y-axis at -1, -2, -3. So this one turns out to be the same. This one goes from -3 up to 3. So y has to be between less than or equal to 3 and -3. So things get a little bit trickier when we start looking at ones where there's not an end to everything. What I mean by that is there's an arrow on the end of this line and the arrow on the end of this line. So if I trace this thing, because there's an arrow, in theory, this thing goes out forever. As I trace along my curve, thing, in this case it's a line, as I trace, it goes to the right forever. There's an arrow. So there's no end to how far to the left it goes. So for left, it goes to negative infinity. That's our symbol for infinity. As I trace along this, it goes to the right forever. So to the right, it goes forever. So infinity. So your domain, there are no limits. And you can write this one of two ways. I'm going to put here all real numbers. Now, math people are kind of lazy writers, so we come up with symbols for stuff. And this double-lined R is the symbol for all real numbers. Now let's take a look at the range. The range is how far up and down. Well, again, this arrow, even though it's going left, it's also going up. So how far up does it go? It goes up forever. We can come over here too. Look at this. The arrow goes up forever. But look, if I go here, that's where its lowest point. It never gets any lower than this point right here. So I'm going to draw a line there. That's the lowest it goes. The lowest it goes is down to -2. And when I scan along this, everything goes up from -2. Everything goes up from -2. It is never below -2. So what you say for the range is y must be greater than or equal to -2. We will do some more practice with this.